Good morning everyone. In today's video lecture, we'll learn about air conditioning system under the course of Pharmaceutical Engineering. Let's start. The term air conditioning refers to the process of treating air so as to control its temperature, humidity, cleanliness, distribution simultaneously to meet the requirement of conditioned space. An air conditioner is an appliance system or mechanism designed to stabilize the air temperature and humidity within an area. In the production area, a desert environment is maintained. Therefore, air conditioning facilities are essential. So, air conditioning is one of the vital component of HVAC system, and the basic mechanism of air conditioning is similar to that of refrigeration. So, why air conditioning is critical in pharmaceutical engineering? So, there is basically two reasons: controlled environment and GMP. So regarding the controlled environment, air conditioning maintains temperature and humidity levels within a tight range, crucial for the stability and efficacy of the pharmaceuticals. You know, in our house, we sometimes use air conditioner, and usually it cools the environment and also dehumidify the environment. Okay, so we can easily understand that by conditioning your air, you can control the temperature and humidity, and both of them is also important for pharmaceuticals because for thermolevel or thermosensitive drug or moisture sensitive drug, you need to control this temperature and humidity. It creates an environment that prevents contamination and product degradation. Then GMP, HVAC system are essential for meeting GMP standards, ensuring compliance with the regulatory bodies like FDA and EMA, that is European Medicine Agency, and that is Food and Drug Administration, helps meet stringent cleanroom standard to protect sensitive drug formulations. So basic components of AC: temperature, humidity, air filtration, and airflow management. Actually, these are the also components of HVAC system. In our previous lectures on HVAC system, we have already learned about that. In the HVAC system, heating, ventilation, and air conditioning. Regarding heating, furnace sometimes are used. Then ventilation, regarding the ventilation, we uh, sometimes use ventilator, okay, or HEPA filter. And regarding the AC, we usually uh, control the air filtration, airflow management, humidity, and temperature. Okay, all of these are controlled. So regarding the temperature control, pharmaceuticals record specific temperature range to remain effective. Okay. Moreover, this temperature control is also important for some thermosensitive drug, and also for capsule shell. For example, for preparation of capsule shell during the hard gelatin capsule or soft gelatin capsule formation, temperature is a critical factor. If the temperature is increased of manufacturing area, then ultimately your capsule shell will get damaged. Okay. Then humidity control. Too much moisture can lead to microbial growth. Too little can cause product instability. Whenever humidity is very high, then the presence of excess moisture can raise the microbial growth. Okay, and sometimes it may uh, be very dry due to the loss of humidity. So both of them is very critical. Then air filtration, high efficiency particulate air HEPA filter removes particulates, protecting both product and personnel from contamination. Then airflow management, proper airflow is critical for ensuring consistent environment condition and preventing cross contamination. Now let's discuss the application one by one. First of all, promoting human comfort. So AC maintains comfortable indoor temperature, typically 22 to 26 degrees Celsius, and relative humidity 40 to 60% for human well-being. Then it also improves the air quality by filtering dust, pollen, and pollutants. Then it reduces the fatigue, improves concentration, and enhances overall quality of life in homes, office, schools, and hospitals. Then industrial and manufacturing process, for example, pharmaceutical industry, regarding completion of tablet, then manufacture of soft gelatin capsule that I have told earlier, then manufacturing of sterile product and injectables, then electronics and precision manufacturing. It prevents damage to sensitive components due to moisture and heat, and also in food processing. Then stability studying chamber. Stability study is one of the crucial thing for testing the degradation study of pharmaceuticals according to the ICS guidelines. So stability testing chamber used in pharmaceutical R&D for accelerated and long-term stability testing of drug, then maintains specific temperature and humidity condition as per ICS guideline. Then maintenance of animal and equipment, for animal house, also temperature control is very important. Provides controlled environment for laboratory animals to ensure the health and reliable research outcome. There are other applications like in hospital and operation theaters, cold storage, then commercial space like hotels, malls, restaurants, auditorium. So this is a common feature of air conditioner. Actually, the components of air conditioner is as like as those of refrigerator that we have discussed earlier. You can see here a compressor, then here is the condenser. Okay, here is the compressor. Okay, here is the condenser, here is the expansion valve, and this is the cooling coil. So from compressor, the gas will come in that direction. So this is the inner side. You can see the wall. Here is the wall. This is the inner side which contains the cooling coil, because the main function of the AC is to cool. Okay. Then this is the outer side. In our rooftop, you sometimes use some fan. Okay. So this is the actually the condenser fan. Okay. This is the condenser which is kept outside of your room. Okay. So cooling coil, cooled air, and this temperature sensitive heat valve. Then indoor air comes in that direction. Then expansion valve. The outdoor air comes here. So this is the overall structure. The flow pattern is like that. Comes here, comes into there, then comes into expansion valve, then it comes into condenser, then again it comes into compressor. Okay. So from compressor it comes into condenser coil, then it comes into expansion valve, then again it comes into the cooling coil. So this is the direction, overall direction. Just keep in mind that what you are giving one after another is very important. Okay. So how it works: the thermostat, which is typically mounted on the wall in a central location within the home, monitors and controls the temperature of the indoor air. The AC cooling process starts when the thermostat senses the air temperature needs to be lowered and sends the signal to the central AC components both inside and outside the home to start running. The fan from the indoor unit pulls hot air from the inside the house through the return air duct. The heat from the air passes through the filter where dust, lint and other airborne particles are collected. The indoor unit blower fan that pumps the chilled air back through the home's ductwork out into the various living areas. The refrigerant gas leaves the home through copper tube and passes into the compressor in the air conditioner unit outside. Compressor works as a large electric pump. The compressor pressurizes the refrigerant gas and sends the refrigerant into the outdoor unit condenser coil. Okay, from where the gas would come into the condenser. A large fan uh, pulls outdoor air through the condenser coil, allowing the air absorb heating energy from the home and release it outside. So this is the overall structure. So during this process, the refrigerant is converted back to the liquid, then it travels through the copper tube back to the indoor unit, where it passes through an expansion valve, which regulates the flow of the refrigeration into the evaporation coil. The cold refrigerant then absorbs most heat from the indoor air and cycles continues. So actually its function is as like as refrigerator. Okay, that we have discussed in our previous lectures. Just to go through this, the basic difference is that in evaporation, the evaporator that we have kept in refrigerator is named as cooling coil. Nothing is different. So there are actually four types of air conditioner. Actually we have discussed one of them, that is split air conditioner system. The figure that we have shown in our previous slides was split air conditioning system. Okay, however, there are window air conditioning system which are sometimes used in hospitals. Then there are centralized air conditioning system, which is the part of HVAC system, or in big hospital or shopping mall we sometimes use centralized air conditioner. Moreover, in our university, uh, you will also find this. Then package air conditioner system, in which uh, actually it is a package of all of the components. Okay, now let's discuss this one by one. First of all, window air conditioner. Actually, in the place of window, this AC is established. Okay, that is why its name it is named after window. Okay, window AC is one of the most commonly used and cheapest type of air conditioner. To install one of these units, you need the space to make the slot in the wall, and there should be some open space behind the wall. Window AC are reliable and simple to install solution to keep a room cool while avoiding the costly construction of central air system. Better yet, when the summer heat dies down, these units can be easily removed for storage and you can use the window still for other purposes. So this is the window air. We sometimes use this. Okay, this is the inner side and this is the outer side of the indoor air. Actually, it is one component. Okay, in split air system, we have seen that yeah, one of the part is in our room, another part is in our rooftop. But here, this is one component. Okay, within the window, we said this. Then split AC, two parts, outdoor and indoor. We have already discussed this: compressor, condenser, expansion valve, and cooling coil. Actually, these three are kept in outdoor unit, and indoor unit contains the cooling coil. Okay, so this is our split air conditioner system, which is most commonly used in our house. Then centralized AC. So in large hall, auditorium, reception areas, we see centralized AC. The centralized AC are used when large building, hotels, theaters, airports, shopping malls are to be air conditioned completely. Actually, in HVAC system, we have seen that how air is supplied through different ductwork within different room. Okay, the window and split air conditioner are used for single room or small office pieces. If the whole building is to be cooled, it's not economically viable to put window or split air conditioner in each and every room. Further, these small units cannot satisfactorily cool the large hall. So this is the system. We can say that this is the part of the central AC. Okay, these are the duct work and also part of the HVAC system. So here overall figure has been shown. This is the room where cold air would be provided. Then air comes into the uh, here is the air conditioner. Then there is supply duct. Actually, this is the part of HVAC system. Central AC circulate cool air through the system and, of supply and return ducts. Okay, so supply duct and resistors carry cool air from the air conditioner to the home. This cooled air becomes warmer as it circulates through the home. Then it flows back to the central AC through the return duct and resistor. Air conditioners help to dehumidify the incoming air, but in extremely humid climates, it may not be achieved low humidity. Running a dehumidifier is necessary to control the RH. So air handling unit. This is the heart of the HVAC system. In air handling unit is the part of the cooling and heating system on a house or building which moves the air through the ductwork. It doesn't condition the air. It is motor and the fan which propels it. The cooling coil cools the air and heating element warms it. The air handler gets the treated air to the vents. Then packaged AC. The window and split air conditioner are usually used for the small air conditioning capacities up to 5 tons. The central AC are used where the cooling load extends beyond 20 tons. The packaged AC are used for the cooling capacities between these two extremes. The packaged air conditioner are available in the fixed rate capacities. These units are used commonly in places like restaurants, telephone exchange, homes, small hall, etc. So this is packaged air conditioner. So how we determine the air conditioning capacity? Okay, The cooling capacity of air conditioner is usually measured in tons. We sometimes say that that is a 1 ton AC, 2 ton AC. Okay, 1 ton equals to 12,000 BTU, with this thermal unit per hour. What is BTU? BTU is the quantity of the heat required to raise the temperature of 1 pound of liquid of water by 1 degree Fahrenheit at the temperature that water has its greatest density, approximately 39 degrees Fahrenheit. The term 1 ton comes from the amount of heat required to melt a block of ice that weigh 1 ton. So this is 1 ton of ice. You need uh, 12,000 energy for melting this. The amount of the cooling required depends on large number of factors like outdoor temperature, outdoor humidity, level of insulation in the house, amount of the air leakage in the house, the amount of the southern, eastern, or western facing glass in the house. Okay, that means your location, in which direction your house is in, whether the glass is single, double, or triple glazed, whether the glass is low emissivity glass, and whether window treatment are kept closed or open, how much heat is generated in the house by the people and equipment inside. Then CFC. CFC is an organic compound that contains carbon, chlorine, fluorine product as a volatile derivative of methane and ethane. A common subclass is hydrofluorocarbon, which contains hydrogen as well. They are also commonly known by the dew point trade name freon. So there has some numerical designation. Actually, we measured this. For example, if I give you like 013, suppose it is a freon name. So how will you calculate this? Your way of calculation would be like, just keep in mind CHF. So these three values suggest CHF. 0 means C, middle one means H, and last one means F. So how? Just plus 1 this and minus 1 this. That means if I tell you that freon 13, what would be the name of the freon 13? Actually, it would be C plus 1. That means 0 plus 1 is equal to C1. Then H, 1 minus 1 is equal to 0. That means no H. Then fluorine. How much fluorine? 3 of the fluorine, CF3. And the remaining one should be filled up by chloride. Okay. And that is why it is called chlorofluorocarbon. That means its number would be CF3Cl. Okay, so overall procedure has been shown here. Just you need to keep in mind that the first one is C, then H, then F. Last number is F. Then for the first one you need to plus 1. For the second one we need to minus 1. And the remaining third one would be as usual. For example, freon 30. We already calculated this. Then freon 11. Freon 11 means 011. Just keep CHF. Okay, so how much C? 0 plus 1 is equal to 1C. That means you and C. Then hydrogen, 1 minus 1 is equal to 0. Then fluoride, how much fluoride? You have only one fluoride. Then the remaining one should be, carbon has 4 hand. Okay, the remaining should be Cl3. That means CFCl3 is your freon 11. Okay, CFCl3 is your freon 11. And the freon 30 is CF3Cl. Actually, you will you can easily understand how I calculated this. So this is the overall lecture from air conditioning system. If you have still any confusion, please inform me in the comment section. Thank you.